projectile word problems using quadratic equations. In this video, we'll examine some physics equations for projectile motion. We'll write equations for situations with objects moving straight up and straight down, and we'll use given equations for situations with objects propelled at an angle. The basic equations for projectile motion involve only the acceleration due to gravity and the initial velocity of the projectile. Air resistance is not taken into account. Now, if you're a regular human throwing a baseball, air resistance could be negligible. But if you're firing something very fast, like a cannonball, or soft, like a Nerf ball, it's going to make a big difference. But we're not going to worry about it in these equations. We're just going to pretend that the things are happening in a vacuum. The trajectory of the object is its path through space, and if that's straight up and down, then we have an equation for the height of the object as a function of time. The height is minus g over 2t squared plus v naught t plus h naught. G is the acceleration due to gravity. It's pulling down, so we give it a negative sign, and it's different if we're measuring in meters or in feet. V naught is the initial velocity of the object, and h naught is the initial height. T in this equation is measured in seconds. Now, if the object is not propelled directly up or released to fall directly down, but fired at an angle, the trajectory will be a parabola. We can use the same basic equation to find the height, but we need trigonometry to calculate the coefficient of the x term since it depends on the angle alpha. If you look at the middle term, it's not just V naught anymore, it's V naught times sine alpha, which will be some fraction of the original velocity. In math problems, though, we give you the equation. So if you don't know trig yet, don't worry. It is important to note, though, that the equation is not the trajectory. That's the height as a function of time. The horizontal axis is time, not displacement. If we want to know the horizontal displacement at any time t, we can use the equation x of t equals v naught cosine t. And again, we're going to give you that equation. A watermelon is dropped from a third-floor window 28 feet above the ground. How long does it take to hit the ground? This is motion straight down, so we're going to use the basic equation and fill in the values. I know the initial height of the watermelon is 28 feet. That's given to me in the problem. Since the watermelon is just dropped and not thrown, the initial velocity is 0 feet per second. And since we're measuring in feet, we're using g equal 32 feet per second squared. So the equation we're going to use is h of t equals negative 32 over 2 t squared plus 0t plus 28. And when we simplify it, h of t is negative 16 t squared plus 28. That gives us the height at any time t. But the question asks, how long does it take to hit the ground? So we want to know what t gives us a height of 0. So we're going to solve 0 equal negative 16 t squared plus 28. Since I don't have a t term, I can just solve this equation by taking the square root. I added 16t squared to both sides, and then I divided by 16. So I have that t squared is 1.75. That means that t is the square root of 1.75, which is about 1.3. Now, what does that mean in the context of the problem? It means that it will take 1.3 seconds for the watermelon to hit the ground. A bottle rocket is launched straight up at a velocity of 39 meters per second. How long does it take to hit the ground, and how high will it go? Again, since this is motion straight up, we're going to use the basic equation and fill in the values. We have an initial velocity in this case. V naught is given to us to be 39 meters per second. The initial height isn't given, so we assume that it's 0 meters. And since we're measuring things in meters, we use the value of g as 9.8 meters per second squared. That gives us an equation for the height as a function of the time in seconds, negative 9.8 over 2t squared plus 39t plus 0. When I simplify, I have h of t equal to negative 4.9 t squared plus 39t. Now the first question is, how long does it take to hit the ground? So that means I want to know when the height is 0. So we're going to solve 0 equals negative 4.9 t squared plus 39t. Now you might notice that we can factor a t out. And so I get t times negative 4.9t plus 39. And that's equal to 0. Now that gives me two solutions. One is t equals 0 because the rocket began on the ground. The other is negative 4.9t plus 39 equals 0. And that gives us t equals 39 over 4.9, or about 7.95. It takes about 8 seconds for the rocket to go up and come back down. Now this height function is a parabola, and it's a down-facing parabola, so its highest point is going to be at the vertex. I can find the vertex by using the formula negative b over 2a, or I can find it by putting it halfway between the two zeros, t equals 0 and t is about 8. Exactly halfway between is when t equals 3.975, so I'm going to round that to 4 and put it in the equation. The height after 4 seconds should be close to the maximum height, and it's negative 4.9 times 4 squared plus 39 times 4. If you work that out with your calculator, you get 77.6. Now that's a height, and it's measured in meters. That's the highest the rocket will go. It will go up 77.6 meters and come straight back down. Now here's a problem where the height function is given to us because the initial velocity of the water leaving the fountain is at an angle. Well, the first question asks, what is the maximum height of the water? And that's going to occur at the vertex of the height function. Well, to find the vertex, I can use the formula negative b over 2a for the t coordinate, and I get that t is equal to 0.14375. So in about 0.144 of a second, we've hit the vertex of this parabola. That's not the height, that's the time. So to find the height, I need to evaluate h at that time. When I evaluate the height function at 0.144, I get 0.455625 feet. And to turn that into inches, I just multiply by 12. It's about 5.5 inches. That tells me how high up it's going to go, so it doesn't hit me in the face when I try to drink a little bit of water. How far across the fountain does it go? Suppose this blue parabola I've drawn is the trajectory parabola. I want to know what is this horizontal distance between where the water started and where it ended. Now that's going to be when the height is 0. So I'm going to solve h of t equals 0 using the quadratic formula, and I'm going to get t equal negative 4.6 plus or minus the square root of 29.16 divided by negative 32, or approximately positive 0.3125 or negative 0.025. Now the negative value is because our initial height was not 0 value, but that's not the one we want. We want the positive one. And what we're going to do is take that value of t and put it in the x equation here. So x of 0.3125 is going to give me the horizontal displacement. And that just means multiplying by 1.02, because that's what the equation says. And when I do that, I get 0.31875 feet. And if I want to have that in inches, I'm going to multiply by 12, and I get 3.825 inches. So the parabolic arc made by the water extends 3.8 inches into the fountain, and its height is 5.5 inches. So here's a problem about a tennis ball launcher, and because the launch is at an angle, I'm given the equation. H is measured in meters, and the height as a function of time is given by negative 4.9 t squared plus 10.3 t plus 0.5. The maximum height is found at the vertex of the height parabola when t equals negative b over 2a. So that's negative 10.3 over 2 times negative 4.9, or negative 9.8, and that works out to be 1.05 seconds. To find the height at 1.05 seconds, I evaluate h at that value, and I find that it's about 5.9. Now that's a height measured in meters, so the maximum height of the tennis ball will be 5.9 meters. Now I want to find out how far the ball travels horizontally. If I think of this green parabola as the trajectory parabola, the height of 0 is going to give me the place where it hits, and that value of t will be the one I can put into the displacement equation. To find t, I'm going to use the quadratic formula, and my two solutions have one a negative, which I'm not going to use, and 2.15 seconds. So when t equals 2.15 seconds, the ball hits the ground, and so I can find the displacement by putting 2.15 seconds into the x formula. X of 2.15 is multiplying 2.15 times 38.6. And that gives me 82.99, or about 83 meters. So the ball will travel up and hit a maximum height of 5.9 meters and come back down and hit the ground 83 meters away from where it started.